Okay, so we're going to start chapter 5. This is section 1 on polynomials. Nomial means term. So we can talk about monomials, mono meaning one, nomial meaning term, one term, or polynomials, poly meaning many, so we have many terms. Anytime you have a plus or a minus sign, that will give you another term. So 3x squared is a monomial because there's no plus or minus. But 3x squared plus 2 is a polynomial because now there's more than one term. Your degree is the highest exponent you have out of all of your terms or all of the polynomials. And standard form is highest exponent all the way down to constant. So you always want to make sure that your polynomial is in standard form before you do anything. We're going to talk about naming polynomials. So we name them with two things, the degree and the number of terms. As you can see here, your degree is constant if you have a degree of 0, linear if you have a degree of 1, quadratic, degree 2, cubic, degree 3, quartic, degree 4, quintic, degree 5. We have term names for terms: monomial, one term; binomial, binomial is two terms; trinomial, three terms. Anything more than three, we can say polynomial of blah terms. So polynomial of 5 terms, polynomial of 7 terms. Same thing with the degree. Anything higher than a 5th degree, you could call it blah degree, 8th degree, 10th degree. So our name is two parts, first part degree, second part term. As you can see here, 3x squared plus 2x plus 1, our highest degree is 2, and we have 3 terms, so we would call this quadratic trinomial. So now that you know the names of the degrees and the terms, let's start naming some. So example A, x cubed minus 2x squared minus 3x to the 4th. We have to put this in standard form first, always. So I can rewrite this as negative 3x to the 4th plus x cubed minus 2x squared. My degree, my highest number is 4 terms. I have 3 terms. So I would call this a quartic trinomial. Right, quartic for a 4th degree, trinomial for 3 terms. Over here in B, I have to simplify it first. I'd have to simplify by foiling, and I would get 3x cubed plus 6x squared minus x minus 2. I can double check to make sure it's in standard form. It is. My highest degree is 3. My number of terms is 4. So this will be a cubic polynomial of 4 terms, because we don't memorize names past 3 terms. I'm just going to write poly because polynomial is a long word. You can write poly as well, or you can write out the full word. We can have some more examples. So C, I have to make sure it's in standard form. That's always your first step. 25x to the 8th plus 10x to the 4th minus 6x squared. My highest degree is 8. My number of terms is 3. So I would call this 8th degree trinomial. Over here, D, we're adding and subtracting. Anytime you subtract, we got to distribute that negative. So we have negative 3x squared plus 4 minus 2x to the 4th plus x cubed plus 5x squared plus 3x. Now that I've simplified, it's not in standard form. So I'm going to start with my highest exponent, which is negative 2x to the fourth. And then I can say x cubed. And then I have, here's a negative 3x squared and a positive 5x squared to give me a plus 2x squared. Then I have my single x. And lastly, I have my constant. Now, fully simplified, combined all like terms in standard form. Your degree is 4. We have 1, 2, 3, 4, 5 terms. So this would be a quartic polynomial of 5 terms. And that's how we name. Again, you always do degree first, number of terms second. So now that you know how to name them, let's talk about the end behavior. The end behavior is literally what's happening at the ends of your graphs. We look on the left and we look on the right. And we can talk about your graph is either going to end going up or end going down. Your turning points are the number of times your graph turns, or what point does your graph change directions. So if we look at this first one here, my graph starting from the left is going down. Okay, sorry, I don't know what that happened there. So my graph is going down, and then right here, it changes directions because now it's going to go up. Oh, here's another point. It's changing directions. It's going down, changing directions, coming back up, changing directions. The number of turning points is always going to be 1 less than the total degree. So I have 4 turning points here, which means I'm going to have a 5th degree polynomial. You can also tell the degree of the polynomial by how many times it changes going up and down. This is what I like to do. I like to count 1, 2, 3, 4, 5. So I know this is a 5th degree. I know that how many turning points it has. It has 4 turning points. And what is the end behavior? We look at the end behavior on the left and we look at the end behavior on the right. And on the left, it's going up, and on the right, it's going down. If we look at this second example, we're going down, and then here's a turning point because now it's going to go up. There's 1 turning point, which means this is a 2nd degree with 1 turning point. I'm going to use TRPT for turning point. On the left side, we are going up. And on the right side, we are ending up as well. If we look at this last one, we have a turning point here. 1, 2, 3, 4, 5, 6, 7. We have 7 turning points. This is going to be an 8th degree function. You can either add 1 to your turning points, or you can count 1, 2, 3, 4, 5, 6, 7, 8, all the way down 8. On the left side, it is ending down. And on the right side, it is also ending down. So we'll talk about end behavior. Is it ending up or down, and on which side, left or right? We can name the degree of the polynomial just by looking at it, and we can count how many turning points there are. Now, if you'll notice, these last two your end behavior ends the same way. This second function is ending up, up, and this third function is ending down, down. Notice there are even functions, second and eighth degree. For any even function, your end behavior is going to be the same. This first function is a fifth degree. It is an odd function. Odd functions end opposite ways. So for an even function, we can end the same. Odd functions, we end opposite ways. So for an even, you can either have up, up, down, down. And for an odd function, you can have down, up, or up, down. So here, if n is your highest exponent, and a, which is your leading coefficient, that's the number in front of your highest exponent, if that a is positive, then the right-hand side, which is where your graph ends, will be positive. If your a is negative, the right-hand side of your graph will be negative. A determines what's going to happen at the very end at the right-hand side. And if it's even, they'll end the same way on both sides. If it's odd, they'll be opposite. So when I say what's the end behavior, for A here, I know that my A is 7, so that's positive. And my N is my highest exponent is even. So because I have an even function, it's going to end the same way, and I want it to end positive, so my end behavior is going to be up, up. Over here, B, if you notice, this is not in standard form, so we have to write it in standard form first. Negative x to the fifth minus 3x to the fourth plus 6x cubed. That's a plus sign. So now my A is negative and my N is odd. So what does that mean? That means odd means it's going to end opposite ways. I know my A is negative, so I know it has to end on the right side going down. Because my N is odd, that means I'm going to have opposites, so I got to be up, down. So the end behavior here would be up, down. We can look at a few more examples. A is in standard form, so I can say my A is negative, and the N is even. So evens are going to end the same way. Negative means going down, so we're going to be going down, down. Here for B, this is in standard form. Your A is positive, and B is odd, so we're going to end opposite. But I know my last one, my right-hand side, has to go up because A is positive, so that means it's going to be down, up. Down, up. And my last one is not in standard form, C, so we have to turn it into standard form. Negative 3x cubed minus x squared plus 5x. Your A is negative. Your N, I don't know why this says B, this should say N. Your N is odd. Odds are going to end opposite directions. Your A tells you the right-hand side, so I know my right-hand side's got to go down. That means my left-hand side has got to go up. And that is how we can tell the end behavior just from the polynomial. Just looking at it, we know what the graph is going to look like. Because of the degree, we can go ahead and tell how many turning points there are and graph a general sketch of what the function should look like.